Imagine a world where you made a different choice. A world where you took that job offer, asked out your crush, or simply decided to have cereal instead of toast for breakfast. Now imagine that all these worlds exist simultaneously, side by side with our own. This is the essence of parallel universes. Parallel universes, also known as the multiverse, suggest that our universe is not alone. There could be an infinite number of universes, each slightly different from the next. These universes might have different laws of physics, different histories, or even different versions of you and me. The concept of parallel universes isn't just science fiction. It's a serious scientific theory with roots in quantum mechanics and cosmology. Some of the world's leading physicists have proposed models that support the existence of multiple universes. If parallel universes exist, it could revolutionize our understanding of everything, from the origin of the universe to the nature of consciousness. It's a theory that pushes the boundaries of our imagination and challenges us to think beyond our everyday experiences.
Quantum mechanics deals with matter and energy at microscopic levels. It's baffled scientists for over a century with its counterintuitive principles. Quantum superposition is key to understanding parallel universes. Particles exist in multiple states until observed. Schrödinger's cat illustrates this, being both alive and dead until checked. This has led to theories of different universes for each outcome. Another concept is entanglement, where particles are interconnected. Einstein called it spooky action at a distance. Some theories suggest entanglement could help detect or travel between parallel universes.
In 1957, Hugh Everett III proposed a radical new interpretation of quantum mechanics. His many worlds interpretation suggested that every quantum event splits the universe into multiple copies. Each copy represents a different possible outcome. Initially met with skepticism, Everett left academia for the defense industry. Decades later, his ideas gained traction. The theory suggests all possible alternate histories and futures are real.
Have you ever had the strange feeling that you've experienced a moment before, even though you know it's impossible? This phenomenon, known as déjà vu, has puzzled scientists and philosophers for centuries. Some proponents of parallel universe theories suggest that déjà vu could be a glimpse into an alternate reality. Perhaps, they argue, we're momentarily accessing memories from a parallel version of ourselves. Another intriguing phenomenon is the Mandela effect. This occurs when a large group of people collectively misremembers a specific detail or event. The term was coined by Fiona Broome, who discovered that many people believed Nelson Mandela had died in prison in the 1980s, when in fact he died in 2013. Some theorists propose that the Mandela effect could be evidence of parallel universes colliding or merging. Critics argue that both déjà vu and the Mandela effect can be explained by more mundane factors. However, these phenomena continue to fascinate those who believe in parallel universes, as they seem to challenge our understanding of reality.
The concept of parallel universes has not escaped the attention of conspiracy theorists. Some believe that governments around the world are secretly researching ways to access or communicate with parallel universes.
These theories often point to classified research projects and unexplained phenomena as evidence of covert multiverse exploration.
One popular conspiracy theory revolves around the Philadelphia experiment, allegedly conducted by the U.S. Navy in 1943. According to the theory, the military was attempting to create an invisibility cloak for ships, but instead accidentally teleported a destroyer escort into another dimension. While there's no credible evidence to support this claim, it has inspired numerous books, movies, and TV shows.
Another frequently cited project is CERN's Large Hadron Collider, or LHC. Some conspiracy theorists claim that the LHC is actually a device for opening portals to other dimensions or parallel universes. They point to the strange phenomena that occur at quantum scales as evidence that the LHC could be manipulating reality in ways we don't fully understand.
The concept of parallel universes has been a goldmine for storytellers in various media. From books to movies to TV shows, the idea of alternate realities has provided endless possibilities for creative narratives. These stories often explore themes of choice, destiny, and the nature of reality itself. They allow us to imagine what-if scenarios on a grand scale. One of the most famous examples is the TV series Fringe, which centers around a team investigating strange events caused by a parallel universe. The show explores the consequences of interactions between two similar but distinct realities. Another popular series, Rick and Morty, takes the concept to comedic extremes, with characters traveling through infinite dimensions, each more bizarre than the last. In cinema, films like the one starring Jet Li, Another Earth, and Coherence have explored the psychological and philosophical implications of parallel universes. Marvel's Spider-Man, Into the Spider-Verse, brought the concept to mainstream audiences with its innovative animation and storytelling. These films often use the multiverse as a way to explore identity, choice, and the road not taken.
Section 7: Scientific theories supporting parallel universes. While the concept of parallel universes might seem like science fiction, several serious scientific theories support the idea. One of these is string theory, a framework in theoretical physics that attempts to reconcile quantum mechanics with general relativity. String theory suggests that the universe is composed of tiny, vibrating strings of energy. Some versions of string theory predict the existence of multiple universes. Another theory supporting the multiverse is eternal inflation. This cosmological model proposes that the universe is constantly expanding and creating new bubble universes. Each of these bubbles could have different physical laws and constants. This theory was developed by physicists Alan Guth and André Linde as an extension of the Big Bang theory. The idea of parallel universes also emerges from the anthropic principle in cosmology. This principle suggests that the fundamental constants of our universe seem fine-tuned for the existence of life. Some scientists argue that this fine-tuning is explained by the existence of multiple universes, each with different constants. Section 8: Challenges and criticisms of the multiverse theory. Despite its popularity in both scientific circles and popular culture, the multiverse theory faces significant challenges and criticisms. One of the main criticisms is that the theory is currently untestable. Since we can't observe or interact with other universes, how can we prove they exist? This lack of empirical evidence leads some scientists to argue that the multiverse theory is more philosophy than science. Another criticism is that the multiverse theory violates Occam's razor, a principle that states the simplest explanation is usually the correct one. Critics argue that postulating an infinite number of unobservable universes to explain our own is unnecessarily complex. They suggest that we should look for simpler explanations within our own universe before invoking parallel worlds. Some physicists worry that the multiverse theory could lead to a kind of scientific defeatism. If every possible outcome occurs in some universe, what's the point of trying to predict or understand anything? Section 9: The search for empirical evidence. While direct observation of parallel universes remains impossible with our current technology, scientists are exploring various ways to find indirect evidence. One approach involves looking for signatures of cosmic collisions. If our universe has collided with another in the past, it might have left detectable patterns in the cosmic microwave background radiation. Another avenue of research involves quantum entanglement. Some theorists propose that particles in our universe might be entangled with particles in parallel universes. If true, this could potentially lead to observable effects. However, detecting such effects would require extremely sensitive measurements and a deep understanding of quantum mechanics. Some researchers are exploring the possibility of using gravitational waves to detect parallel universes. The idea is that gravitational effects from other universes might be detectable in our own. Section 10: Our fascination with parallel universes. The concept of parallel universes continues to captivate both scientists and the general public, but why are we so fascinated by this idea? One reason might be that it offers a way to explore the roads not taken in our lives. The idea that every decision creates a new universe allows us to imagine alternate versions of ourselves living out different possibilities. Parallel universes also appeal to our sense of wonder about the unknown. Just as early explorers were driven to map uncharted territories, we are driven to understand the fundamental nature of reality. The idea that there might be entire universes beyond our own is a modern frontier, challenging us to expand our understanding of what's possible. For scientists, the multiverse theory offers potential solutions to some of the most perplexing problems in physics. It could explain the fine-tuning of physical constants, resolve paradoxes in quantum mechanics, and provide a framework for understanding the nature of reality itself.